Good afternoon, everyone. I am Piyush Shande, BT at 37. So, today our topic of presentation in deep learning is layer normalization versus a batch normalization. So, first of all, we're gonna see introduction to normalization. That what is normalization in deep learning? Purpose of normalization is to improve a training speed and stability. Normalization reduces internal covariate shift disturbance changes in a layer inputs. Common normalization techniques include a batch normalization and a layer normalization. Then we're gonna see what is batch normalization. Normalize activation function over mini batches for each feature independently. Uses batches, mean and variance during training. Requires sufficiently large batch size for the stability. Okay. Then next we gonna see what is layer normalization. Normalize activation function feature for each data independently. Does not depend on a batch size. Computes mean and variance per input sample. Useful in small batches size and sequential model like RNNs and transformers. So our next slide is key difference between the layer normalization and a batch normalization. We have three columns. First is aspect, second is batch normalization, and third is layer normalization. So we see firstly aspects. Normalization axis in batch normalization across the batch, in layer normalization across the features. Then dependency on band size. In batch normalization require large batch size, in layer normalization independent of batch size. Then aspects are training versus interference. In batch normalization, different behavior for training and interference. In layer normalization, same behavior for both. Then suitable modes. In batch normalization, CNNs and feed-forward neural network. In layer normalization, RNNs, transformer, variable batch size. Computational overhead in batch normalization higher, in layer normalization lower. Then the advantages and drawbacks of a batch normalization and a layer normalization. Okay, so for the batch normalization, speed up training is an advantage, improves generalization and less effective with a small batch size. And for a layer normalization, works well with a small or a varying batch size, stable training for sequential model like RNNs and transformers, and then slightly slower conversion in large batch setup. Use case and applications. In batch normalization, image classification, computer vision task using CNNs. And second is large dataset with stable batch size. Then in layer normalization, natural language processing NLP model like BERT and GPT. Recurrent neural network RNNs, speech recognition. Then third is reinforcement learning and generative models. Our next slide is a summary and conclusion. Batch and layer normalization address different needs in deep learning. Batch normalization excels with a large datasets, batches, and CNNs. Layer normalization is versatile and curricular for a sequence and small batch size task. Choice depend on a model type, data, and computational concerns. Thank you for listening and watching.